Okay, so let's take a look at this question. So a particle p moves in a straight line. The speed of p at time t seconds, where t is greater than or equal to 0, is v meters per second, where v is equal to at squared plus bt plus c, and a, b, and c are constants. When t is 3, the speed of p has its minimum value. When t is 0, v is 28, and when t is 3, v is 1. So we have to find the acceleration of p when t is 4, and this is 8 marks. It's a quite a long question. So what I'm going to do is I'm actually going to break this up into its 3 constituent parts. So this we can say is the first piece of information we're gonna look at. This will be the second, and this over here will be the third. And we're going to use these 3 pieces of information in order to solve this. So the one thing I want to do is, although we've been given this information, it's always good to translate it into equations, so you can properly combine the pieces of information together. So we're going to start with piece number 1. So when t is 3, the speed of p has its minimum value. So what this essentially is telling us to do is differentiate, so dv over dt, and set it to 0. As when we think about a quadratic, it's got a shape like that. Its minimum value is at the bottom right here, and that has a gradient of 0. So by setting dv over dt to 0, by substituting the value of t as 3 in, that will essentially give us that gradient. So when we do this, we know that v is equal to at squared plus bt plus c. And therefore, differentiating this gives us 2at plus b. Substituting t in when t is equal to 3, we get 6a plus b. And we're going to set that to 0 because 2a times 3 is 6a. 6a plus b is equal to 0. I'm going to just box this as our first piece of information. Then number 2. So it's telling us that when t is 0, v is 28. This essentially tells us the y-intercept of the function is 28, because we know that v is equal to at squared plus bt plus c. When t is 0, at squared plus bt becomes 0, and therefore you're just left with c. So c is going to be equal to v. In this case, v is equal to 28, so we can say c is equal to 28. That's our second piece of information. And then our third is when t is 3, v is 1. So we know that v is equal to at squared plus bt plus c. Substituting t is 3 and v is 1, we get 1 is equal to 9a plus 3b plus c, and c is 28 in this case, as we deduce from this information. And rearranging it, we get 9a plus 3b is equal to negative 27. Divide everything by 3, and we get 3a plus b is equal to negative 9. Now we have our 3 pieces of information, we can combine them. So what we're going to do is we're going to use simultaneous equations with equations 1 and 3 to get what a and b are, since we already know what c is. So if we write them out, so 6a plus b is equal to 0, and then we have 3a plus b is equal to negative 9. And what we can do is we can use the elimination method to subtract equation 2 from equation 3 from equation 1, and we get 3a is equal to, so negative 9 is positive 9, so 3a is equal to 9, and a is equal to 3. So we got a, now we can get b. So let's use this equation over here. So 6a plus b is equal to 0. Therefore, 6 times 3 plus b is equal to 0, since a is 3. So b plus 18 equals 0. B is equal to negative 18. Oops, let me write that. 18. Now we have to find the acceleration of p, as we've debunked what a, b, and c are. So we can say that v is equal to 3t squared minus 18t plus 28. That's our equation. So find the acceleration of p when t is 4. So the acceleration is equal to the derivative of v with respect to time, which is dv over dt, which is equal to 6t minus 18 in this instance. T is equal to 4 can now be substituted in here to give us 6 times 4 minus 18, which equals 24 minus 18. And this is equal to 6 meters per second squared. So therefore, the acceleration is equal to 6 meters per second squared. And that's our final answer.